Hey everybody, today we're going to be talking about active transportation. So active transportation is a method of transportation by the cell membrane that does require energy from the cell itself. It's basically substances entering or leaving the cell while the cell spends no energy or ATP in order for this to occur. We'll be focusing on four kinds of active transport here. Endocytosis, exocytosis, and then the subtypes, Pinocytosis and Phagocytosis. Endocytosis, in very simple terms, is when a cell takes in a substance. Endo literally means inside or internal, which will help you remember this. Exo, on the other hand, means outside or external. But we'll get to exocytosis later. But anyways, personally, I like remembering the difference by thinking of Freddy Fazbear from the hit horror game series Five Nights at Freddy's, because like the robots in the game have an endoskeleton inside of them. See that? Endoskeleton inside? Yeah, I'm assuming. But anyways, so endocytosis, it's all about bringing things inside the cell. And the two methods of endocytosis we'll discuss are phagocytosis and pinocytosis. Firstly, phagocytosis. In Greek, phago literally means to eat or consume, so that should pretty much foreshadow what phagocytosis is all about. A good example of phagocytosis would be an amoeba. An amoeba is a unicellular organism that hunts for its nutrients. When an amoeba finds food, it'll use its pseudopods, and these pseudopods are they're basically cell hands, like when a cell pushes its cytoplasm out against its cell membrane to push out these arm-like shapes from the cell to surround, swallow, and engulf nutrients, be it food particle, even another organism. From there, the amoeba lives another day on, and so forth. So, phagocytosis, it brings things into the cell through consumption, which is why it is kind of endocytosis. Next, pinocytosis. In Greek, pino means drink. Pinocytosis is basically the same thing as phagocytosis, but instead of consuming a solid substance, a fluid substance is being absorbed in order for the cell to take in its nutrients and such. And so this is done in multiple ways. One of these ways is when a vesicle will move up to the cell membrane, and get this is pretty crazy. It'll move up to the cell membrane, right? And it'll essentially fuse with it and make a little gaping pocket on the exterior of the cell to take in, kind of absorb any surrounding nutrients. And then once the food particles have been obtained, the vesicle will retreat back to the cell, back to its original form, but loaded with food this time. So now for exocytosis. Exo as in external, of course. So exocytosis is when a cell spends energy taking things out of it. Now ask yourself, what would a cell need to get rid of? Waste. And what organelle delivers things through, from, in, and out of the cell? Vesicles. It's basically pinocytosis, but in reverse. Instead of popping into the cell membrane to take any surrounding nutrients, the vesicle will pop out to dump waste. And just like that, active transport through exocytosis has been performed. So I mean, yeah, that's honestly kind of all I got to say. But usually I don't really do this, but because when I'm learning this stuff myself, I kind of just read books or look stuff up, or maybe I learned it at school, right? But this video, the organic chemistry tutor, that one super smart guy on YouTube, he literally carried this entire video. So I just gotta say that because this guy literally explained all this to me first. So yeah, hopefully you learned something. Maybe you didn't. Let me know if something's wrong or if there's a better way to explain it. And yeah, I guess that's it. I guess I'll see you in the next one.